Hello everyone, we are going to discuss the problem sliding subarray beauty. So we are given an array nums which contain n integers. So we need to find the beauty of every subarray of size k. So what is beauty? The beauty of a subarray is the smallest kth smallest integer in the subarray if it is negative, and if it is not negative number, so we need to put 0 on that place. So we need to return the n minus k plus 1 size integer array which denote the beauty of all the array starting from the first index. And if we take an example number 1, so let's take an example number 1. So in this example we are given the size of the subarray will be 3, and we need to return the second smallest element. So if we take the first subarray of size k, that will be 3. So it is 1 minus 1 and minus 3. And what will be our second smallest element? That is minus 1. So minus 1. Again, if we take the subarray of like this size, so this is minus 1, minus 3, minus 2. What will be our second smallest element? Second smallest element will be minus 2. Again, if we take this subarray, so what will be our second smallest? Like minus 3, minus 2 and 3. Second smallest will be minus 2, so minus 2. So this will be our result. Make sense? Again, how do we approach this question? The first part of this question is think about the data structure. That what data structure we have to use? We have to use heap or DQ or something else. So you need to think about the data structure, like how do we approach this question? So if we see the constraints, okay, so the given n is 10 to the power 5, that is pretty big, but the given num is between minus 50 to 50. So it is sure that our nums, I mean the values in the array, will be between minus 50 to 50. Okay, so if let's say we make a map of frequencies between these numbers, is that it will make sense? Let's see how. Again, we take the example. So in this example, we need to find the second smallest element for every subarray of size 2. So if we make a map like minus 1, that will appear one time, minus 2, that will appear one time. So it will be a subarray of size 2. And actually, what is map? Map in C++ will arrange all the elements in the ascending order. We are using ordered map. It is like ordered dictionary in Python, and in Java I don't know. So what will it will do is it will arrange all the elements in a sequential manner, like from in sorted order, and it will count the frequency of all elements. So let's say if we are arranging this like arranging them like this. So our x is given as 2. Okay, so we will find the first element that will appear after find the xth element in the map, and it is pretty simple because all the values in the map will be between minus 50 to 50. So if we traverse map every time, like for every value of n, that will be 10 to the power 5. If we traverse on the map, that will be max to max 100. So it will go up to 10 to the power 7, which is also pretty less than 10 to the power 8. So it will work. It will definitely work. So let's see how. If we take this example, and we are given this one is minus 1 and this one is 1. So what will be the second smallest element? So we see how it is happening. Like if we take from up to down, that will be from in increasing order, and we will see what will be the frequency of that element, like how many elements I am taking so that I will get the element that is at the xth position. Okay, make sense? So if we take in this example minus 1, minus 1 will be at the first, then we will take minus 2, -2 will be at the second position. So second position will be this. So for doing this, we will take a counter, and in counter, initially the counter will be 0. We will push back the first element in the counter, that will become 1. Then we'll push back the second element in the counter, that will become 2. So if the counter will get greater than or equals to x, so what we will do is we will insert that element into our array. Make sense? And that element will be -2. So for this case, answer will be -2. Again, I'm gonna remove this element from the map and inserting this element from the map. That is our I and our J. Okay, we insert like -3. The structure will be like not this way. The structure will become this. So for this, again, -3 will be the second smallest. Then again, we will in remove -2 and we will insert 4. So we will remove -4 and we will insert -2 and we will insert 4. Again, -4 will be the answer. Again, we will remove -3 and insert -5. So -5 will be the answer for this case. So this will our resultant array. Similarly, we will do for all the subarrays. So if we see its implementation, like what I did, simply I insert all the elements in the map. Then I will check like which element appearing at the x position, and the element appearing at the x position I will place it into the answer, and if the answer will be smaller than 0, then we will push it into the result, and otherwise I will push 0. Again, we will check in the window our, like we have to create the window. So in the window we will remove the first element and we will insert the next element, and again we will find like which element appearing at the x position, and whatever the element appearing at the x position we will insert it into the answer, and finally we will return the answer. So it will work. Okay, thank you.